Hi everyone. In this video, I will explain the third form of plane passing through one point and parallel to two vectors. How to find out equation of plane containing one point and parallel to two vectors. Well, equation of plane passing through vector equation of plane passing through A of A bar and parallel to two vectors B bar and C bar is given by R bar equal to TB bar plus SC bar, where T comma S are scalars, or box of R bar minus A bar, B bar, C bar equal to 0. Why this is so? Here you see that the plane is parallel to two vectors B bar and C bar vector, and it passes through a point A of A bar. If you take any general point on the plane, that is P of R bar, now joining with A, you will get AP bar vector, right? And parallel to B bar, you draw a vector on the plane. This is parallel to B bar vector. And parallel to C bar vector, this is C bar vector, or you just move those vectors onto the plane. Now you see that AP bar, B bar, C bar are coplanar vectors. So as they are coplanar vectors, so we write that AP bar is equal to sum T into B bar vector plus S into C bar vector. Well, so here AP bar is nothing but R bar minus A bar equal to TB bar plus SC bar. Therefore, we got that equation of plane passing through only one point and parallel to two vectors. This is the vector equation of plane. Or you can say that box of AP bar, B bar, C bar is equal to 0. That's why we got box of R bar minus A bar, B bar, C bar equal to 0. Now we use this box of R bar minus A bar, B bar, C bar equal to 0 when they explicitly give the point A and the vectors B bar and C bar. Now I will explain that equation of plane passing through one point parallel to two vectors in different modes. Well, so here you see equation of plane passing through only one point A x1, y1, z1 and parallel to how many vectors? Here two vectors parallel to two vectors. Assume that this is the B bar vector and this is the C bar vector. Right. So now we can give these parallel vectors explicitly, or we can give in other format. What are the other formats? Like perpendicular to two planes. A plane perpendicular to two planes, you can say, right? Well, here you see that suppose this is the plane 1 and this is the plane 2. So assume that this is the plane 1 and this is the plane 2 and this is the required plane. Okay. So here you see that required plane is parallel to the normal of both the planes. So what is the normal to the plane 1? Normal to the plane 1 is A1I plus B1J plus C1K. Both are equal. And plane is also parallel to A2I plus B2J plus C2K. Whether they will give this parallel to which vectors that plane is, or they can give perpendicular to two planes. Or the third combination is parallel to two lines having DRS A1, B1, C1 or and A2, B2, C2. Having DRS parallel to two lines having DRS is nothing but that plane is parallel to these lines, right? So this is B bar vector and this is C bar vector. Or there is a combination of line and plane. There is a combination of line and plane. Perpendicular to one plane and parallel to one line having DRS. Right. So here, this is C bar vector. Okay. So you look at the diagram. This is C bar vector. And this is the plane 1. This is the plane 1. So required plane is pi. This required plane is perpendicular to the plane 1, which means that its normal is parallel to the required plane. So this vector is A1I plus B1J plus C1K. Isn't it? Well, and that plane passes through the point A of X1, Y1, Z1. Or there are several combinations. For all these combinations, there is only one formula. Containing a line L and perpendicular to the plane. This is the plane 1, perpendicular to the plane 1. So perpendicular to the plane 1 is nothing but that plane is parallel to the normal of this plane. Isn't it? Normal of this plane. So this is A2I plus B2J plus C2K. When a line L lies on the plane, which means that plane is parallel to that line and also passes through that point X1, Y1, Z1. Right. Or they can give that containing one line and parallel to another line. So this is parallel to A2I plus B2J plus C2K. These are all different situations of obtaining equation of plane in one format. Now a line, it contains a line. This is the line. This line contains the point that is X1, Y1, Z1. Or containing two lines. Equation of plane containing two lines. Okay. This is A1, B1, C1. And I am changing. This is A2. This is B2. And this is C2. For all these, there is only one formula, that is determinant of x minus x1, y minus y1, z minus z1. The first one represents that r bar minus a bar. The second row represents parallel to vector b bar. Third row represents parallel to the vector c bar. This is nothing but box of r bar minus a bar, b bar, and c bar. So your aim is to find out one point on the plane and parallel to two vectors. You always try to find out one point on the plane and parallel to two vectors. Those two vectors will be given directly or will be given indirectly. Like in the form of lines or like in the form of planes for which those planes are perpendicular to required plane. So for all these, this is the formula. Well, here is one question. If the equation of plane passing through the point and perpendicular to each of the planes, right? So perpendicular to each of the plane means that plane parallel to 2i 3 plus 4j plus 5k and plane also parallel to 3i minus 2j plus 3k. So there are two parallel vectors, not sorry, the plane is parallel to two vectors and it contains one point. So without hesitating, you just apply that determinant is equal to 0. So this is x plus 2. This is the point. Y minus 3, z minus 5. And perpendicular to first plane, nothing but parallel to its normal. Parallel to its normal. 2, 4, 5. Perpendicular to second plane, nothing but parallel to its normal. Minus 2, 3, equal to 0. Just by expanding this determinant, you will get the answer very fast. Now x plus 2 into, this is 12 plus 10, that is nothing but 22 minus of y minus 3 into, it is 6 minus 15, that is minus 9, plus z minus 5 into, it is minus 4 minus 12 minus 16 equal to 0. Something odd we got. Okay, they are asking that what is alpha plus beta plus gamma. This implies you will get 22x plus 9y, okay, minus 16z. This is 44, right? And this is 80. So 80 plus 44 is nothing but 122. And subtract 27. Okay. So we got the answer that 80 plus 44 is 124. Okay. This all simplification part you can do minus 27. That is nothing but plus 97 equal to 0. So therefore, this alpha is equal to 22, beta equal to 9, and gamma equal to minus 16. It is so straightforward question. Let P be the plane containing the straight line. All right. So we have a line on the plane, which means that line plane passes through 3 minus 4, 7. So there is a point on the plane and also parallel to 9i minus j minus 5k. Now we need one more vector to which the plane must be parallel. So instead of that, they have given that perpendicular to the plane containing two straight lines. Well, okay, we'll do it now. So in order to explain very clearly that, assume that this is the line 1 and this is line 2. Okay. So pi 1 plane containing line 1 and line 2. Pi 1 is the plane contain line 1 and line 2. Right? Then now you see normal to the plane 1 perpendicular to L1 and L2. Okay. So normal, let the normal of pi be n bar. Be n. This is pi 1. Okay. So pi 1 is the plane containing given lines L1 and L2. Then n bar is perpendicular to L1 and L2. L1 and L2. Right. So which means that n bar is parallel to that 2i plus 3j plus 5k cross 3i plus 7j plus 8k. Well, okay, right. So this is nothing but that n bar vector I can take as a determinant of, this is like what is vector perpendicular to a bar and b bar, that is a bar cross b bar. So I, j, k, 2, 3, 5, 3, 7, 8. This is equal to 30 I into 24 minus 35. Sometimes I stuck 24 minus 35, that is 9. Minus 9. Minus j into this is 16 minus 15 plus k into, it is 14 minus 9. So these are it is normal of the plane containing given two lines plus 5k. You can assume just like it is a C bar vector. You can assume like a C bar vector. Now what is the equation of plane containing one line and perpendicular to another plane? Right. Containing this line. Right. Now it is easy that containing this line and parallel to this vector. So determinant of the first line passes through 3 minus 4, 7 and parallel to the vector, this is parallel to the vector 9i minus j minus 5k. So parallel to two vectors and passing through one point. Now the required plane is given by determinant of that x minus 3, y plus 4, z minus 7, parallel to two vectors 9 minus 1 minus 5, and parallel to second vector that is minus 9 minus 1 and plus 5. Oh, we got all right. So this implies that x minus 3 into, it is minus 5 minus 5 minus 10 minus y plus 4 into, this is 45 minus 45, 0. 45 minus 45. And plus z minus 7 into, it is minus 9 minus 9 minus 18 equal to 0. All right, let me see once again that d is the distance of the plane from the point 2 minus 5, 11. Okay. So we have to find out what is the equation of plane. This is nothing but you can cancel by minus 2, then you will get 5x. There is no y term plus 9z minus 15 plus 63. Minus 15 minus 63. Minus 78 equal to 0. All right. Now we need to find out the perpendicular distance 2 minus 5, 11. 2 minus 5, 11. So perpendicular distance is equal to modulus of 5 into 2 plus 9 into minus 5. Okay, sorry. This is, there is no y. In fact, there is no y, only z is there. So z is 11. Z is 11. So 9 into 11 minus 78 whole by root over. This is 45 plus 81. 45, sorry, 25 plus 81. Root over 25 plus 81. This is equal to, I'll simplify and I'll write the answer. Yeah, now once again, I myself correcting that this is 24 minus 35. This is minus 11. This is minus 11. So I have to adjust here. This is minus 11. All right. X minus 3 into this is 10, right? Y plus 4 into minus of. This is 45 minus 55. 45 minus 55 is nothing but minus 5. And this is minus 9, minus 11, minus 20. This is minus 20. Well, now I'll simplify this. I can write the perpendicular distance. Well, here is the equation of plane. I'll redo this calculations once again. Okay. So here this is nothing but that x minus 3 into this is minus 5 minus 5 minus 10 minus of y plus 4 into 45 minus 55 minus 10 plus z minus 7 into this is minus 9 plus minus 11 minus 20. You just cancel by minus 10. You will get x minus 3 minus y minus 4 and plus 2z minus 8 equal to 0. This implies x minus y plus 2z and it is minus, this is 14. This is 14. So you got minus 21 equal to 0. Now we need to find out that perpendicular distance from 2 minus 5, 11. 2 minus 5, 11. So the perpendicular distance D is equal to modulus of 2 plus 5 plus 22 minus 21 whole by root 6. So by doing square, you will get 8 into 8 by 6. That's equal to 32 by 3. There is another question of straightforward. A plane P is parallel to two lines whose direction ratios are directly given. Nothing but parallel to minus 2i plus j minus 3k minus I plus 2j minus 2k. right? That is the plane and containing the point. So point given, parallel vectors are also given. Let P intersects the coordinate axis at A, B, C, making intercepts alpha, beta, gamma. Nice. If V is the volume of tetrahedron OABC, O is the origin, and rho is equal to alpha plus beta plus gamma, then what are these? Very simple question. Okay. So now we will obtain the equation of plane P very directly, that determinant of it passes through the point 2, 2, minus 2. So x minus 2, y minus 2, and z plus 2. Parallel to two vectors, nothing but having parallel to two lines having DRS are given minus 2, 1, minus 3. Second line is parallel to the vector minus I plus 2j minus 2k equal to 0. So x minus 2 into expanding the determinant minus 2 plus 6. That is nothing but 4 minus of y minus 2 into this is 4 minus 3, 1 plus z plus 2 into this is minus 4 plus 1, nothing but minus 3 equal to 0. So therefore, this implies you will get 4x minus y minus 3z and calculate what is the constant here, minus 8 plus 2, nothing but minus 6, and minus 6, that is minus 12. This is the plane equation, right? We need x, y, z intercepts of this plane. Okay. Well, so this implies you just send this 12 that side, send this minus 12 that side, and divide by 12. You will get that x by 3 plus y by minus 12 plus z by minus 4. That's equal to 1. Okay. So this is the x-intercept alpha, y-intercept beta, z-intercept gamma. We got it, right? Now asking what is the volume of tetrahedron. So here A coordinates are that 3, 0, 0, 0, and B coordinates are 0, minus 12, 0, and C coordinates are 0, 0, minus 4, and that origin is 0, 0, 0. So what is volume of tetrahedron? Volume of tetrahedron V is equal to 1 by 6 into modulus of box of OA bar vector, OB bar vector, and OC bar vector. This you will get directly determinant, that is nothing but 1 by 6 into modulus of x-intercept, y-intercept, z-intercept. That's equal to 1 by 6 into 3 into 4 into 12. This is equal to, you will get 48. That's it. And alpha plus beta plus gamma is minus 13. So 48 comma minus 13 is the answer. That is option A is true. And I think one more question I would like to solve. The largest value of A for which the perpendicular distance of the plane containing two lines. This is the plane containing two lines. I didn't solve this kind of question. A plane containing two lines from the point 2, 1, 4. Right. So now the required plane is given by determinant of, see, first line passes through 1, 1, 0. That's enough. That's enough. X minus 1, y minus 1, z minus 0. First line parallel to this vector, 1, a minus 1. And the second line parallel to this vector, minus 1, 1, minus a. This is equal to 0. All right. Okay, so this implies x minus 1 into This is minus a square plus 1. So you can say 1 minus a square. Minus of y minus 1 into minus a minus 1. Minus a minus 1. And plus z into, this is 1 plus a. Z into 1 plus a. This is equal to 0. Asking what is the largest possible value of a for which the perpendicular distance of the plane containing two lines from 214 is root 3. You can see that I think you can cancel a plus 1. For a not equal to minus 1. For a not equal to minus 1. You can cancel that. So you will get x minus 1 into 1 minus a plus y minus 1 plus z equal to 0. Well, so this is the plane equation. We got that 1 minus a into x plus y plus z plus a minus 2 equal to 0. Now perpendicular distance from 214 is root 3. So write the perpendicular distance formula. So the perpendicular distance from 214, root 3 is equal to the perpendicular distance from 214 is modulus of 1 minus a into 2 plus 1 plus 4 plus a minus 2 whole by under root 1 minus a whole square plus 1 plus 1. This is equal to, you will get modulus of minus a and calculate what is the constant. It is 2 into 1, 2 plus 1, 3 plus 4, 7 minus 2, that is plus 5 whole by under root. This is a square minus 2a plus 3. Now just squaring both sides and cross multiplying, squaring both sides, you will get 3 into a square minus 2a plus 3. On the other side, you will get a square minus 10a plus 25. You just need to simplify it. Then you will get 2a square. It is minus 6a plus 10a, nothing but plus 4a. And this is a 9 minus 25, nothing but minus 16 equal to 0. We got that a square plus 2a minus 8 equal to 0. You will get either a is equal to minus 4 or 2. So they are asking what is the largest value of a. The largest value of a is 2. Thank you. Keep watching my channel and enrich your knowledge. I am leaving the last question, which means you can do it.